Okay, in this lesson we are looking at the third type of model that we are studying in this unit, and that is the exponential model. Now there are two types of exponential graphs. Okay, an exponential graph can either increase or decrease. So if the relationship is increasing, we call that type of a function an exponential growth function. Okay, so this one on the left is an example of exponential growth. And if your quantity is decreasing, then we call that an exponential decay function. And we'll be speaking more about those two types of functions later on in this unit, actually in the second part of this unit, and we'll be looking at how to come up with equations for these types of relationships and so on and so forth. For now, we want to have a look at the table of values for an exponential function. And in the table of values for an exponential function, there is a common ratio between successive pairs of y values. And what that means is there's no particular pattern in the first or second differences for exponential functions, but there is a different type of pattern. That is, there's no adding or subtracting pattern, I guess we should say, for the y values. But the pattern is that we are always multiplying by the same value. So for example, if we look at our row of y values here, 4 divided by 2 is 2. There we go. And 8 divided by 4 is also 2. So in other words, we're multiplying by 2 all along the bottom here. So 8 times 2 is 16, and 16 times 2 is 32, and so on. So because of that common ratio, we know that this is an exponential function. In particular, in this example, your quantity each time is doubling. That's a fairly typical example for exponential growth. And so we have some terminology that goes along with that. The length of time it takes a substance to double in size or value is called the doubling time, which seems to make sense. Okay, and similarly, often we will look at examples where your quantity is decreasing by half, or the length of time it takes your quantity to decrease by half. Okay, so we refer to that as the half-life. So we often speak of the half-life of, say, a radioactive substance. So how long does it take for that substance to decrease by 50% of its original size? So looking at this next example here, it says find the doubling time for the population that's modeled in this graph. So what that means is find the length of time it would take for this population to double. So if we look at the initial value of the population here, it appears to be about 25, maybe slightly less than 25. So we are looking for the time it takes for that population to double. So how long does it take for that population to reach 50? So if we look on our graph, we can see that it takes about 3 months for that population to double in size. So if we want to make a note here for our steps, so we notice the initial value was about 25. So when looking for the doubling time, we're looking for the time it takes to reach 50, okay, is approximately 3 months. So therefore, the doubling time is about 3 months. Now notice, we didn't necessarily have to use the initial value. So for example, I could look at where, let me grab a different color here. I could look at where the population is at 50, so after 3 months. And how long does it then take the population to grow to 100? Because 2 times 50 would be 100. So if we look at that on our graph, we see that's still approximately 3 months. Or the time it takes to go from 100 to 200, right, is approximately 3 months, slightly less than. Okay, so it doesn't actually matter what 2 points you look at, but you want to look in terms of your y values, right? Either how long it takes to go from 25 to 50, or 50 to 100, or 100 to 200. So how long does it take for your population to double? Okay, in an exponential growth or decay function, there's only one half-life or doubling period. So it doesn't matter which 2 pairs of values you choose to use to find that, you will still get the same answer. Okay, and there is an example in your homework of that asks you to find the curve of best fit for an exponential model. So you'll want to refer to your instructions from the last lesson, the regression instructions. And I believe the exponential regression option is option 0 on the screen where you choose the type of regression. Okay, if you have any further questions about that, just let me know. And that concludes this lesson.